session. Good evening. I remain Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall look at the transitive property of relations. Please, before you continue with this video, it is highly recommended that you view the videos in the playlist in order. Okay, you have to view those videos in order so that it will make sense to you. The video playlist on my website on relations, it is highly recommended that you view those videos in order. Then it will make sense to you. So in this video session, we shall talk about transitivity, or the transitive property of relations. We say that a relation R is transitive. A relation, say R, is transitive on a set, say A, if for all A, B, C, we are now introducing C. For all A, B, C, element is an element of set A, then if then, okay, if for all A, B, C is an element of set A, then AB is an element of arrow and BC is an element of the relation arrow, implies that AC is an element of R. So ABC are elements of set A. Then if we see that this other set, A, B, is an element of R, and that B, C is also an element of R, then A, C should be an element of the relation R. That is the definition. If we want to write this in predicate logic, then we can say for all A, for all B, for all C, AB is an element of arrow, and if we're writing it in predicate logic, and BC is an element of arrow, okay, implies, let's close this here and close this right here, implies that AC is an element of R, and we can close this. So that is this in predicate logic. That is it in predicate logic. Another way you can define this, this is one definition, this is another definition in predicate logic. You can also say that for all A, B, C, so let me just write mark asterisk on this, okay? This is the definition, this is another definition. For all A, B, C is an element of A, okay? Then A relation B and B relation C implies A relation C. A relation B and B relation C implies a relation C. So that is what we mean by transitivity, saying that a relation is transitive on a set. Okay, that is what we mean by that. So any of these, that's fine. So another way is this. Okay, what if you do not have, notes? If you do not have the ABC, okay, if you do not have ABC, and we shall look at examples so it will make sense to you. Just like we treated reflexivity and symmetry, we are going to treat transitivity the same way. So if you don't have the case whereby you have the ABC, okay, or you might have A and B, then A and C without having B and C. Okay, if you don't have that case, you have to look out. The main thing here is you have to watch out for these two cases here, AB and BC. If you have AB and you have BC, then you must have AC. If you have AC in all those cases, then the relation is transitive. If there is any case, remember these properties, okay? If you identify even one case whereby it does not hold, then the relation is not transitive. So if there is any case you have AB and you have BC, but you do not have AC, then the relation is not transitive on the set. Now, if there is no case at all whereby you have AB, BC, AC, then the relation is still transitive. Okay? It is transitive. The relation is transitive if no case. The relation R is transitive on the set, say A, if there is no case. If there is no case of AB, BC, AB, if you don't have any case of that, if there is no case like that, AB and or BC, okay? If you don't have any case like this, AB and or BC, if you don't have any case like that, then we say that the relation is still transitive. If you don't have any case like that, then we say it is still transitive. Okay? So, the only time we say that it is not transitive is if you have A relation B and B relation C, but then you don't have A relation C. Okay? If it's not transitive, when we say it is not transitive, is when you have A relation B and B relation C, but A not relation C. Then we say it is not transitive. That is the case you say that it is not transitive. Okay? So, let us now solve examples. Remember from what we have been doing before, we will do the sets, then we do matrices, and we do digraphs. Okay? What we did on reflexivity, symmetry, we did the sets, then we did matrices, 0, 1 matrices, then we did digraphs. But here we shall do the same thing, but let us go ahead and do sets and matrices, together. Let's do it together. Let's see. Let's look at this. Let's do it together, sets and matrices. Then we now talk about digraphs. So, example, question 1. Let's say we have A to be set of 1, 2, 3. And let's say we have the relation to be the set of the ordered pair 2, 3. Okay, let's look at examples. So let's say we have that set, and let's say we have the relation to be that 2, 3 only. So if you look at this now, this is not a case whereby you have you don't even have ABC. Like in the relation, you look at the relation, you only have something like A and B. If you say let small a be 2 and let small b, lowercase a to be 2, lowercase b to be 3, then you don't have C, you don't even have lowercase c. So if there is no case of that, okay, A, B or B, C, you don't have those cases, just like you have here, we say that R is transitive. Okay? Since there is no case, okay, no case of C, R is transitive on set A. That's the way that's the way we look at it. Okay, let's look at, because I want us to do both sets and matrices together. Let's represent A as matrix. Okay, let's represent A as matrix, and let's see if they give you the relation as a matrix, as a 0, 1 matrix. How would you know that it is transitive? So we have A and A. So we have A and A. So 1, 2, 3. 1, 2, 3. And then the relation we have here is only 2. 2, 3 only. So 1, 1 we don't have it. I put 0. 1, 2 we don't have it. 1, 3 we don't have it. 2, 1 we don't have it. 2, 2 no. 2, 3 is what we have in the relation. Okay, I'm representing this relation as a matrix, as a 0, 1 matrix. Okay, so 2, 3 is the only thing we have. 3, 1 no. 3, 2 no. 3, 3 no. So this is the relation here. How would you know if they give you this? Let's say they give you this relation as a matrix. Okay, remember in the main topic we did on relations, I explained how you can represent relations as 0, 1 matrix. So this is that relation here as a matrix. How would you know if it is transitive? So what you could do, you have 2 ways to do this. You have 2 ways to do it. If you have a 2 by 2 or 3 by 3 matrix, okay, this one is pretty much straightforward to look at it. We have only 2, 3. So, and we don't even have the other case, like BC. We don't have BC. We don't have BC, no case of C. Or you can also say no case of BC. No case of BC. We don't have that. We only have, like, say, case of A and B. So, you could just look at this matrix right away and you say it is transitive. Right away. You could look at it that way. Okay? So you can just do inspection. If they give you the relation as a matrix, you could just do inspection and say, okay, we have only 2, 3 as the ordered pair in the relation. Okay, we don't even have the other case, and we don't have the other case. Remember, it has to be AB, BC, then we look for AC. So, because you don't have those cases, you only have one ordered pair. You can just say by inspection that it is transitive. Well, that is one way. Okay, what if you have 1, 0, 1, 1, 1, 0, and the rest of them? Another way you could also do this is, you multiply, square this matrix. Okay, square it. That's find r squared. Square the matrix. Once you square the matrix, you look at the result, the product. Any non-zero elements of the product, look for it in the actual matrix. Okay? If you see any non-zero element in the product, look for that position. Look for that corresponding element in the original matrix. If it is 1, great, it is transitive. If it is 0, if it is non-zero in the square of the matrix, but it is 0 in the matrix itself, it is not transitive. Okay, I will still explain what I just said. Now, but let's go ahead and square this. Let's go ahead and square this and square this matrix. Okay? So if we square this matrix, r squared, let's find r squared. So this will be 0, 0, 0, 0, 0, 1, 0, 0, 0 times 0, 0, 0, 0, 0, 1, 0, 0, 0. So this is a 3 by 3. This is a 3 by 3. And because the number of columns of the first, the number of columns of the first matrix is the same as the number of rows of the second matrix, they are conformable. And of course, you will know that they are conformable because you are just squaring them anyway. Alright, so this will be row by column, okay? Row by column, 0 times 0 plus 0 times 0 plus 0 times 0, 0 times 0 plus 0 times 0 plus 0 times 0, 0 times 0 plus 0 times 1 plus 0 times 0. There are scientific calculators on my website that you could just use if your professor says you don't need to show your, this is if your professor says you should show your work, then you now do all these, okay? But if the professor does not really care, then you could use scientific calculator to do it, or you could use Excel. Okay, we've done videos on how you could use Excel. You can also use Google spreadsheets to multiply this. Okay, so if you also look at this one, this is row by column, 0 times 0 plus 0 times 0 plus 1 times 0. Okay, this one is 0 times 0 plus 0 times 0 plus 0 times 0. Plus 1 times 0. 1 times 0. Then this will be 0 times 0 plus 0 times 1 plus 1 times 0. 1 times 0. The last one, this is 0 times 0 plus 0 times 0 plus 0 times 0. 0 times 0 plus 0 times 0 plus 0 times 0. Then 0 times 0 plus 0 times 1 plus 0 times 0. So this will now give us what? The first one, this is 0, 0, 0. This here will be 0, 0, 0. We have 1 times 1 here. 0 times 0 plus 0 times 1 plus 1 times 0, yeah. Okay? Now you know how to check this actually. You know how to check it to make sure it's right. So if you look at the last elements, okay, we discussed this in multiplication of matrices. It's all on my website. So if you look at this, actually, you all have, looks like you all have zeros. Okay? 0 times 0 plus 0 times 1 plus 1 times 0. Okay, so you all have all zeros here, 0, 0, 0. So in this case, you ask yourself, do we see any non-zero? Do we see any non-zero element here? No. But, okay, we didn't see any non-zero element. So this is still transitive. R is transitive. Okay, because there is no case. No case. It doesn't apply. So there is no case. But assuming, and we shall get to that, we shall do more questions. Assuming we see a non-zero element, assuming we see a non-zero element here, we look at the position, the location of that element. We look at that corresponding position here. If it gives us 1, then it is transitive. If it gives us 0, it is not transitive. Remember I said non-zero. Okay. Here we don't have any non-zero. If you don't have any non-zero elements when you square the matrix, okay, the relation represented as a matrix. If you don't have any non-zero element, if you do not have any non-zero elements in the product, then the relation is transitive. Okay. But if you have a non-zero element, then you find the position, then look for the corresponding position in the original element. If that corresponding position is 1, okay, all the non-zero elements, look for their corresponding positions. If their corresponding positions are 1, then the relation is transitive. If their corresponding positions are 0, if any one of the corresponding position is 0, then the relation is not transitive. Okay? So let's see, let's do another example so it will make sense to you. Let's do another example. Example 2. Question 2. So let's say the relation we have here, let's say we have the relation to be, we have 1, 2, we have 2, 3, we have 1, 1, okay, we have 2, 2. Look at this for a moment, folks. Okay, let's look at this for a moment. So here, actually, let me put it this way. Let me put it in order. 1, 1, 1, 1, 2, 2, 2, 2, 3. Okay, let's look at this for a moment. So here we have 1, 1. Then we have 1, 2. Okay, we have 1, 2. We have 2, 2. So we have 1, 2. So that one will work. Then we have 1, 2. We have 2, 3. But we don't have 1, 3. So let me say this. Look at what I mean here. Okay. So we have 1, 1. And we have 1, 2. So we have 1, 2. So see, we have 1, 1. And okay. A, B, B, C. We have 1, 2. Okay. Implies we have 1, 2. So no problem. This works. Remember, this is. Let me write this first. Remember, this is AB and BC should imply AC. Okay. So here we have 1, 1, and we have 1, 2, and this implies 1, 2. Okay? It's there, no problem. I mark it, no problem. Then we have 1, 1, and we have 2, 2. Okay? AB, BC, AB, BC. Yeah. And this implies 1, 2, AC. AB, BC, AB, BC. 1, 2. This, we all have this. No problem. No problem. We have this. You know, this is, you know, doing it by sense. You have to really be careful, especially if you have many other pairs. Let's say this was 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, and you have the relation as many other pairs. If you have, this is 3 by 3 matrix, so it's not a problem. Then what if you had 5 by 5 matrix, 6 by 6 matrix? So you have to, if you're doing it this way, you have to really be careful. Now, the next one, we have 1, 2, and we have 2, 3. Okay? So, but we don't have 1, 3. No. We don't have this. And that's a problem. That is a problem. So that's a problem. So because you have at least one case you have AB and BC, but you don't have AC, even just one case of it. Therefore, we say that arrow is not transitive. We now say that arrow is not transitive on set A. It is not transitive on set A. If you have no case at all, no problem. It is transitive. If you have all the cases, no problem. Perfect. It is transitive. But if you have some cases where it is and another case, or just even one case where it is not transitive. It is not. All right. So let us now do this as matrix. Let's see. Assuming they give you this in matrix form, how would you know? How would you know that it is not transitive? Let us represent this arrow. Let's represent arrow in a matrix form first. Let us represent it in matrix form. Then we now do inspection. This is 3 by 3 matrix. You can inspect, you know. Or you just multiply. You just multiply, because I just want to show you how this, you know, you find arrow squared. I want to explain to you how you can find out. Because if your professor does not care about you showing your work, and if it turns out that the relation is 6 by 6 matrix or 7 by 7 matrix, just use the calculator on my website, or use Excel, or use Google Spreadsheet and multiply it. You know, square it. That's multiply it. And then just easily find out. Otherwise, if you do inspection, it's gonna take your time. Well, depending on the question anyway, depending on the question. Okay, let's first of all represent this in matrix first. Okay, so that we can multiply, and then you see what I'm talking about. So at least we now, you know, I like to do mine this way. You have 1, 2, 3. You have 1, 2, 3. And later I will delete this. So this is our arrow. 1, 1 is there, so I put 1. 1, 2, yes, is there. 1, 3 is not here. 2, 1 is not here. 2, 2 is there. 2, 3 is there. 3 is not 3. 1, 3, 2, 3, 3 is not there. So I can erase this now. All right. So assuming you were given this in matrix form, and you are asked to find, you were just given this. Let's say they didn't give you this here. They didn't give it to you. They gave you this. And you were asked to find whether this is transitive. You could, if you want, and the thing is that you could change from one to another. You could go ahead and do digraph, or if they give it to you in matrix, you can put it right in set form. So anyway, if they give it to you in sets, you can change it to matrix and do it. Or they give it to you in matrix, you can change it to digraph and do it. We shall come to digraph later on. Or if they give it to you as a digraph, you can convert it to matrix and do it. Or you can convert it to sets and do it. Interconvertible, right? Interconvertible from one form to another. So, but let's say they just gave you this as a matrix. You could just do inspection. If it is a 5 by 5, 6 by 6 matrix, you might go with inspection, depending on it just depends on the question, okay? You could just do the inspection, okay? If I have 1, 2, and 2, 3, I have 1, 2, I have 2, 3, but I don't have 1, 3, okay? I have 1, 2, I have 2, 3, but I don't have 1, 3. Here, I don't have 1, 3. Okay, then that is inspection. But if you ask me my suggestion, I will say this. If the relation is a 2 by 2 or 3 by 3 metric, well, if you ask me my suggestion, this is what I would say. If the professor wants you to show your work, okay, let's say the professor gave it to you as a matrix and says you must do it as a matrix form. You can't convert to sets, or you can't convert to digraph and do it. Okay, and then you must show your work. Okay. If it is a 2 by 2 or 3 by 3, or even 4 by 4 matrix, solve it. Multiplying it is not a problem. It's not. Okay? Multiply it, square it. Forget about inspection. Because in inspection you might mess up. Okay, if the professor says don't convert. Okay. So, but then if the professor says he doesn't mind you showing your work, go ahead and use spreadsheets or calculators and square it and easily compare the product and the main relation. And it's easy as that. Trust me. Okay? Now, when you have 5 by 5 or 6 by 6, and then you have to show all your work, then you might need to use inspection. You might need to use inspection than coming to multiply it. Okay? So let's go ahead now. This is 3 by 3, so we can do it. Let us go ahead and square this. Find r squared. So we are going to find r squared. Of course, they are conformable. So our arrow, let me just erase the whole thing here. Our arrow squared will be, we have 1, 0, 0 by column, 1, 1, 0, 0, 1, 0. Remember, we said that this is not transitive. Remember, we said that arrow is not transitive. On set A. Okay, but we now want to do it by matrices. So we multiply, we square these two matrices, we multiply them. 1, 0, 0, 1, 1, 0, 0, 1, 0. Okay. And we have done multiplication of matrices. Okay. It is on the video playlist on matrices. Multiplication of matrices. So here we multiply row by column. So this is 1 times 1 plus 1 times 0 plus 0 times 0. You break. You have 1 times 1 plus 1 times 1 plus 0 times 0. You break. Then you have 1 times 0 plus 1 times 1 plus 0 times 0. You close. Okay, you close. Row 2, you have 0 times 1 plus 0 times 1 plus 1 times 0 plus 1 times 0. You break row by column. Okay? Row by column. Then you have 0 times 1 plus 1 times 1 plus 1 times 0. You break. Then you have 0 times 0 plus 0 times 0 plus 1 times 1 plus 1 times 0. You close. Row 3, you have 0 times 1 plus 0 times 0 plus 0 times 0. You break. You have 0 times 1 plus 0 times 1 plus 0 times 0. You break. Then you have 0 times 0 plus 0 times 1 plus 0 times 0. You close. And you want to make sure you did it right. You check the ends. 1, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 1, 0, 0, 0. Just to make sure it rhymes. So now this will give us, this is gonna give us, this is gonna give us, this is gonna give us what? What is it gonna give us? Gonna give us. So this is 1 plus 0 plus 0, 1 plus 1 plus 0, 0 plus 1, 0 plus 1 plus 0, okay? Then 0 plus 0 plus 0, right? 0 plus 1 plus 0, 0 plus 1 plus 0, then 0 plus 0 plus 0, 0 plus 0 plus 0, 0 plus 0 plus 0. So now our answer will be 1, 2, 1, 0, 1, 1, 0, 0, 0. Okay. Now the next thing you do here is, let us circle all non-zeros. Let's circle all the non-zeros. Circle the non-zeros. Circle all non-zeros. Non-zeros. In the product. In the product. Circle all non-zeros in the product. In the product matrix. In the product matrix. So I'm going to circle this. So look at their position. You look at their position, right? Okay. Then I'm going to come here also. Circle all non-zeros in the matrix. Circle all non-zeros in the matrix. circle all non-zeros. Non-zeros in the matrix. Okay? Also. So I'll circle this, circle this, circle this, circle this. Now, if you identify any one that is non-zero here, that is a zero here, if you identify even one case, then the relation is not transitive. And you see that case. You see that case is this case here, 1, 3. That's the case. So you have 1, 2, 2, 3, but you don't have 1, 3. That is a problem. You see, the rest are fine. 1, 2, 1 here, 1 here, 2 here, 1 here. Okay, the rest are fine. But if you have even one case of non-zero in the product matrix that is a 0 in the actual matrix, okay, the relation, then the relation is not transitive on set A. If you don't have any case here of non-zeros, like the first one we did, no problem. The relation is transitive. If you have any case here that it is non-zero, but it is a 0, that same position is a 0 here, then the relation is not transitive. Okay? Alright, now let's go ahead and do this again. Let's now do a case whereby we now put 1, 3. Okay, let's now do a case whereby we put 1, 3. So, what if we now put 1, 3? What if we go ahead, question 3? This is question 3. Okay, question 3. Let's go ahead now and put 1, 3, then 2, 2, 2, 3. So I'm going to put here 1, 3, then 2, 2, 2, 3. Okay? So let's put it as matrix. We have 1, 1 is here, 1, 2 is there, 1, 3 is there. 2, 1, no, 2, 2, yes, 2, 3, yes. Okay? So this is what it will give us here. This is what it will give us. I want to save time in this video. I want to save time. So that's why I'm using the same thing, just making little changes. So if we put that 2, 3, okay? And if we put 1, 3, yeah, this is what was missing. Okay. So let's go ahead now and multiply this. This is now 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. So this will be, all our 1, 3s will change it. 1 times 1 plus 1 times 0 plus row by column. Third one here, plus 1. 1 will be here, okay? 1 times 1 plus 1 times 0 plus 1 times 0, okay? 1 times 1 plus 1 times 1 plus 1 times 0, this will be 1 here. 1 times 1 plus 1 times 1 plus 1 times 0, 1 here, okay? Then 0 times 1 plus 1 times 0 plus 1 times 0, no problem. So the affecting it will now be this one here. So 2, 3. 0 times 1. Actually, this is 1 row by column, row by column, row by column. 1 times 1. 1 times 1 plus 1 times 1 plus 1 times 0. Okay? Then 0 times 1. 1 will be here, and also 1 will be here. Okay? So let's look at it again. Row by column, 1, 1, 1, 0, 1, 0. That works. 1, 1, 1, 1, 1, 0. Okay? 1, 1, 1, 1, 1, 0. All right. Second row, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0. Okay. 0, 1, 0, 0, 0, 0. Okay. 0, 1, 0, 1, 0, 0. Okay. 0, 1, 0, 1, 0, 0. All right, folks. Yeah. So this works. Let you know. This is okay now. So this will be 1 plus 0 plus 0. 1 plus 1 plus 0. All right. 1. This will now be 1 times 1 is 1. 1 plus 1 plus 0. Then 0 plus 0 plus 0. 0 plus 1 plus 0. 0 plus 1 plus 0. Okay, and this is 0 plus 0 plus 0. Yeah, so this is still okay. And this will now give us here, we have 1 plus 1 plus 0. So this is 2 here. This will be 2. That is the only thing that changes here. 2. We still circle it. And then when we now look at this here, if we circle here, if we now circle the non-zeros here, okay, we now see that yes, that it is transitive. That arrow is transitive. Arrow is transitive on set A. That's it. Okay, so if there's no case, it is transitive. If there are all the cases, it is transitive. If there are some cases and some cases that are not, it is not transitive. You just know that. Let's see how digraphs will work, and then we solve more problems, and then we can call it a night. Okay. Let's see how digraphs will work, and then we can solve more questions, and then we can call it a night. Remember what I said, if you have a 4x4 or 5x5, and your professor does not care if you show your work like I did, then use scientific calculator. Use the calculators on my website on matrices to multiply it, or use Excel, Microsoft Excel, or use Google Spreadsheet. Okay, we've done videos on how you can use Microsoft Excel to multiply matrices. Okay, so if you are allowed to use graphing calculators, scientific calculators, then just square it and do it. Especially when you have 5x5 or 6x6. Doing inspection, I don't encourage it. Okay. All right. Now, how does the digraphs work? This is now. Let's look at the because we've done sets, we've done matrices. Now let's do the digraphs. How would the digraphs work? How will it work? With the digraph, you have to look at it this way. If you have an edge from node 1 to node 2, and an edge from node 2 to node 3, then you must have an edge from node 1 to node 3. Must. If you don't have edge from this to this and this to this, no problem. If you don't have any case, no problem. Remember what we said. If you don't have any case, no problem. Okay? So let's first of all, let's do digraph of this and see how it works first. So we have 1. Let me put 2 here. 2. And let me put 3 here. 3. So we have 1, 1 is a loop. Okay? We have 1, 2, 1 to 2. This is for the digraphs. 1 to 2. We have 1 to 3. the edge from 1 to 3. Then 2 to 2 is a loop. Some textbooks will say cycle of length 1. Some textbooks will say cycle of length 1. But it's a loop. Okay. And then you have 2, 3. So as you can see here, you have a complete triangle. But you have to wash your arrows very well. You have to wash your arrows very well. As you can see, if you have transitive property, you would have a complete triangle. Or you would have no triangle at all. It depends. It depends. With digraphs, just look at it before you now conclude. This is my suggestion. My suggestion is this. If you are given a digraph, if you're given a digraph, change it to sets or matrices. Okay, if you're not good with diagrams, some people like digraphs. They like visual, some people are visual folks, visual learners, but some are not. So if you're given a digraph, change it to sets, then, change it to sets and then find out, or change it to matrices and then find out whether it is or not. Let's do examples. Let's do more examples. This is example 3. Let's do more examples. So let's say we have this digraph right here. Example 4. For me, I will still do, depending on how the digraph is, I might not change it to sets. I can just look at it that way, and find out, because sometimes it's also used by inspection. I will say just inspection method to find out. So we have a digraph here. We have 1, we have 4 here, we have 2, we have 5, and we have the 3 here. Okay. So here you have 1 to 4, 4 to 1, and then 1 to 4. Okay, that's a two-way street. You have 4 loops to 4. You have 4 to 5, 4 to 5. You have 1 to 5. You have 1 to 2. You have 2 to 5. You have 3 to 2. 3 to 2. Okay, you are asked whether this is whether this digraph is whether the relation is transitive or not. Okay, so let's see here. You have 1, 2, 2, 5. So you have 1, 5. So remember, we have AB and BC implies to give us AC. It's always good to write this out first. Okay, let's look at that digraph for a moment. We have 1, 2, and we have 2, 5, and then we have 1, 5. Okay, I will use yellow chalk. This works, no problem. Remember, it has to work. If we identify it, it must have to work everybody. Then we have 1, 4, 4, 4. Okay, we have 1, 4, 1 to 4, and we have 4, 4, which is a loop. Okay, and we still have 1 to 4. That's fine. This works. It works. We have 1, 2. We have 2, 5, and 3, 2. Okay, we have 1, 1, 5, Okay, I'm looking at all the ways you could have. You have 4, 1, and 1, 5, and 4, 5. Okay, that works. You have 4, 1, and 1, 5, and 1, 5 to give you 4, 5. This works. You have 4, 1, and 1, 2, but you don't have 4, 2. You see, that's a problem. We just identified a case. Okay. You have 4, 1, and 4, 2, but no, sorry, 4, 1, and 1, 2, my bad. You have 4, 1, and 1, 2, but no 4, 2. No 4, 2. You don't have no 4, 2, so this is no. And if you identify just one case, it is not transitive. Arrow is not transitive. Okay. Some people will not want to, some people like it as sets. I don't know, some people might do that. So for those people, let me just write this also as sets. Okay, for those people. So you could have the set, you could have the arrow as a set to be, we have 1, 2, we don't have 1, 3, but we have 1, 4, we have 1, 4, we have 1, 5, then we are done with ones. Okay, being the first. 1, 2, 1, 4, 1, 5. Then we have 2, 2, 5, then we have 2, 5. Okay, then 3, we have 3, 2, we have 3, 2, okay, 3 is all over. 4, we have 4, 1, we have 4, 1, then we have 4, 4 as a loop. We have a loop 4, 4, okay, and that is it. Then 5, 5 we actually don't have 5. So we have 1, then we have 4, 5, I mean, then 4, 5, yeah, 4, 5. Okay, this is what we have. 1, 2, 1, 4, 1, 5, 2, 5, 3, 2, 4, 1, 4, 4, 4, 5. Okay? You count the arrows in 1 from 1. From 1 going towards other ones. You have in ones, you have going from 1, you have 1, 2, 1, 2, 3. 3 arrows. Then 2, from 2, you have only 1 arrow. From 3, you have only 1 arrow. From 4, you have 2 arrows. 1 is a loop. 2 arrows going from 4, okay, to itself. 4, 4, and 4, 1. And well, 3 arrows actually. And then 4, 5, 3 arrows. So 3 plus 1, 4 plus 3 plus 1, 4 plus 1, 5 plus 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? 8. You can do it going from that to that, or coming towards. So just make sure you count it. And then you can see you have 4, 1 and 4 and 1, 2, but you don't have 4, 2. So that means arrow is not transitive. Okay? Alright, the next one, let's do another one. Question 5. What if you have let A be the set of integers. So let A be the set of integers. Okay? Be the set of integers. And R will be the relation, R be the relation on set A where a relation B, if and only if, remember this is logic, if and only if A plus B is a multiple of 5, okay? A plus B is a multiple of 5. All right. And the question says, determine if it is transitive. Determine if it is transitive. Okay, so let's see this. What if we have this here? We would be interested in finding any case whereby it is not, or we keep doing, if you have, because this is a lot. I mean, set A to be the set of all integers, it is infinite. You can't list all the elements. So, but the relation must be that A plus B is a multiple of 5. Must. So, let's say, so the relation could be, what could the relation be? The relation is that A plus B must be a multiple of 5. So we could have 1 plus 4, and multiples of 5 is like 5 times 5k, okay, where k is an integer. So it could be 5, 10, 15, 20, 25, 30. So 1 plus 4 is a multiple of 5. 2 plus 3, 10. 3 plus 7. I'm just giving examples, okay? But let's see if we can find 1, 4, and 4 plus 6. Okay? So if we have 1, 4, remember this should be AB and BC. BC implies AC. So if we have 1, 4 and 4, 6, okay, it should imply 1, 6. It should imply 1, 6, right? If you have this kind of question, you should just be concerned about how to find any case that does not work. Okay, has to be a multiple of 5. So 5, 10, 15, 20, 25, 30. So in this case, we have 1, 4 and 1, 6. It should imply 1, 6. But when we do 1 plus 6, but 1 plus 6 is 7. 1 plus 6 is 7. Okay, 7 is not a multiple of 5. 7 is not a multiple of 5. Therefore, arrow is not transitive. Okay. So, because if you're looking at the arrow would be this set. 1, 4, 2, 3, 3, 7, 4, 6. This is what you're going to look at if you put the arrow. Okay? Arrow will be 1, 4, and so on, because it's not, I'm going to put this, and it's, and so. It's too much. It's too much to list. Too much. But at least you have a case. You have a case here whereby you have 1, 4 and 4, 6. It should imply 1, 6. Now 1 plus 6 is 7. 7 is not a multiple of 5. So you can say arrow is not transitive. Arrow is not transitive. It's not transitive. Okay? Comprende? Comprenez-vous? Do you understand? Do you understand? Another one. Let's do another question. Example 6. What if you have a matrix? This is a 1, 2, 3, 4, 5. 5 by 5 matrix. They gave you a 5 by 5 matrix. So you have 1, 1, 0, 1, 0. 1, 1, 0, 0, 1. 0, 0, 1, 0, 1. 0, 1, 0, 1. 0, 0, 0, 0, 0. 0, 1, 1, 0, 1. Okay, so you have this matrix here. You have this matrix. You're asked to find whether it is transitive or not. I mean, you know, with this case, like I said earlier, if your professor allows you to use graphing calculator, okay, does not mind you showing your work, just square this. Square it and then circle all the non-zeros in the product, okay? And then compare it whether it has non-zeros in the actual matrix. If your professor wants you to show your work, okay, multiplying this will take us time, trust me. It's gonna, if I have to multiply this 5 by 5 matrix, I will have to erase the whole board. So, if your professor wants you to show your work, maybe you do by inspection. Okay? By inspection. Now, if you don't mind multiplying, then good luck. Okay? I mean, it still doesn't matter. I can multiply it. Just, you have to be careful. Okay? Because you have to have a 5 by 5 matrix. So you can just do by inspection rather than by multiplying, by multiplication. So remember, we need AB and BC to give us AC. That is what we need. That is what we need. So we can do, and you know, this is like saying 1, 1. I can write this here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1, 1 is there. 1, 2 is there. 1, 4 is there. I mean, you could write it as a set, or you could inspect it directly here. You could inspect it directly here. So you have 1, 2, and you have 2, 2. So yeah, 1, 2 and 2, 2 will give you 1, 2. That's fine. Now you have 1, 1, 2 and 2, 5. Okay, you have 1, 2 and you have 2, 5. Does it give you 1, 5? 1, 5, no. So you could see right here immediately. You have 1, 2, 1, 2, and you have 2, 5. Right? So you should have 1, 5. No. By inspection, okay, just like that, you see you have 1, 2 is there, and you have 2, 5. So this should give you 1, 5. But as you can see, 1, 5 is not there. So did not give you. So no, it didn't give you this. Therefore, arrow is not transitive. If you can identify just one case, then it is not transitive. And some people might want to put it as set and then do it. Okay? Now, if your professor didn't strictly say you must do it as matrix, then you can put it as set and then do it. So if we put it as set, 1, 1 is there, we have 1, 2 is there, we have 1, 4, we have 2, 1, 2, 1 is there, we have 2, 2, we have 2, 5, 2, 5, we have 3, 3, 3, 3, we have 3, 5, we have 5, 2, 5, 2, we have 5, 3, and we have 5, 5. Okay? So you can put it as set if you want to. Alright, so and then you can now do it by sets, if you want to. The next video we might have to do will be just solving problems, word problems, just like the way we did number 5, like solving the word problems. But at least this gives you an idea of the properties of relations. We did reflexivity, we did symmetry, and in this video we just finished transitivity. If you have any questions, please feel free to ask. Thank you so much for listening to this video presentation. And you have a good evening.